Good evening, children.
Good evening, ma'am.
Good evening.
Good
Good evening,
Good
children.
evening.
Yeah, good evening. All right. So this is the last part of number systems, which is exponents. And after this, we also have this geometrical representation of, rational and irrational numbers. That one I need to check to what extent you've learned in school because some portions are deleted. So I'll check that with you and then teach you. All right. So other than that, this is the last part of number system. So after this, we'll start polynomials. Okay. So see this one, children. How do we simplify 3 to the power 1 by 2 multiplied by 3 to the power 1 by 3? So exponents, we know when bases are same and its multiplication, we can add the powers. When bases are same and its multiplication, we add the powers. So write the base ones, 3, and add the powers, 1 by 2 plus 1 by 3. So you know how to add 1 by 2 and 1 by 3. LCM. Okay. So 5 by 6. 3 to the power 5 by 6. Okay. So this one simplifies to 3 to the power 5 by 6. All right, children. So today you're not working anything. I'm going to teach you a couple of, questions. I'll share the material, the presentation with you in the library. So you can go there and work it out later. All right. So you're just going to listen to me today. And if you have any questions, you can ask them and get them clarified. Yeah. Now here you see that the bases are different, but the powers are the same. The bases are different, but the powers are the same. So the rule is a to the power m into b to the power m. See, bases are different. A, B. Bases are different. A, B. But the powers are the same. M is equal to a into b, the whole power m. Multiply the bases and raise it to the same power m. When bases are different, but they raise to the same power, multiply the bases and raise it to the same power. So if you want, I can write the rule here. What is the rule here? The rule is a to the power m into a to the power n. Bases are same. A, 3, A. Multiplication. Powers are different. Mn. Powers are different. So what do you do? Write the base and add the powers m plus n. Here, bases are different. A to the power m into b to the power m is equal to a into b the whole power m. So 2 into 3 the whole power 5 by 8, which is 6 to the power 5 by 8. All right. Yes or no, children? Understand this?
Yes, ma'am.
Very good.
Yes, ma'am.
All right. Now look at this one. The bases are same. 625, 625. The bases are same. It's multiplication. The powers are different. The powers can be the same also. Not that they have to be different. What you see here is the bases are same and it's multiplication. So the rule is when bases are same, so A, and it's multiplication. The powers here are like m and n. So when bases are same and it's multiplication, we add the powers. Write the base and add the powers. So it will be 625 to the power 0.16 plus 0.09. So 1 carried over 0.25. So we know that 0.25 can be written as 25 by 100. 0.25 can be written as 25 by 100. All right, so it's 25 by 100. And that simplifies to 1 by 4. 1 by 4. So we have 625 to the power 1 by 4. 625 can be written as 5 raised to the power 4. 625 is 5 raised to the power 4. And there's already another power 1 by 4. So multiply that power. When there are many powers, multiply the powers. See, it is 5 to the power 4, the whole power 1 by 4. So you can multiply the powers. So it's 5 to the power 4 into 1 by 4. So 4 and 4 cancels and the answer is 5. So value of this expression is 5. The value of this expression, what is given here, is 5. Now, supposing I ask you what is the time now? What's the time now? And you say the time is 625 to the power 0.16 into 625 to the power 0.09. Okay, PM. You say that and you say PM. So I don't understand the time. So when I simplify, I get 5. Oh, the time is 5 PM. The time is 5 PM. That's what you meant by saying this. That's what you meant by saying this. So the value of this expression is 5. All right. So it's the same here. That's what I worked here, children. So you can see add the powers. 0.25 is 25 by 100, which is 1 by 4. Multiply the powers, 4 cancels, and 5. So Sabarna, tell me the 2 laws of exponents which we just recalled from 8th standard. A to the power m.
A to the power m into a to the power n can be written as a to the a plus a m plus n.
A to the power a raised to the power m plus n. A raised to the power, or simply a to the power m plus n. Very good. Very good. Sadhana, what is the other one? What's the other one?
A to the power m into b to the power n.
N or m?
M, ma'am.
Ah.
It's a into b to the power m. Or
Whole
to
power
the
n.
power m.
Very good, girls. Very good. Okay. So now what you should understand is we have laws of exponents, with the mathematical operations, multiplication and division. We don't have much for addition and subtraction. Addition, see now, if it is a to the power m plus a to the power n, okay, a to the power m plus a to the power n. There is no meaning with there is no law like a to the power m plus n for this. No. When the connecting sign is a plus or a minus, there is no law of exponent. Only when the connecting sign is multiplication or division, a to the power m divided by a to the power n is a to the power m minus n. When it's division, we subtract the powers. When it's multiplication, we add the powers. When it's multiplication, we add the powers. But if the connecting sign is plus or minus, for that we don't have any law. So how do we simplify in such cases? How do we simplify in such cases? All right. So here first, this can be simplified using the law. And this also can be simplified using the law. But the connecting sign here is minus. But we can simplify this one. So here it will be 2 to the power 55 plus 70. Correct? 125 minus 2 to the power. What is 153 minus 28? 125. So on simplifying, you get 2 to the power 125 minus 2 to the power 125. Something minus the same thing is 0. See, like you have something minus the same thing is 0. So 2 to the power 125 minus 2 to the power 125. So they get cancelled. The answer is 0. Yeah, go through, children. I'll just wait for some time so that you understand. Don't write, go through the steps. Any questions, children?
No, ma'am.
Okay. All of you, please respond. Any doubts?
No, ma'am. No, ma'am.
Okay. Now see here. So here we start working from the outermost radical. The outermost radical. The outermost radical is this one. This is the outermost radical. Now we know that, let's recall this. Let's recall this one. Square root means to the power 1 by 2. Cube root means to the power 1 by 3. Fourth root meaning to the power 1 by 4. Fifth root meaning to the power 1 by 5. So nth root meaning to the power 1 by n. Now what do I mean by this? Supposing you have cube root of 10. This is said to be in the radical form. Radical form. Now when you write this as 10 to the power 1 by 3. This is the exponential form. Exponential form. Cube root in the exponential form is to the power 1 by 3. To the power 1 by 3. Write this 10 as it is. This 10 becomes the base. Cube root becomes 1 by 3, the power. Now, supposing you have square root of, say like 10 to the power something like 1 by 4, and you have a 5 here. Okay, so it's the fifth root of 10 to the power 1 by 4. Write this one as it is. Write this one as it is. That becomes the base. This one becomes the base. And the power will be fifth root becomes 1 by 5. Fifth root becomes 1 by 5. So now this is nothing but 10 to the power 1 by 4 into 1 by 5. Because what we know is when there are many powers, we'll have to multiply the powers. So it's 1 by 4 into 1 by 5, which is 10 to the power 1 by 20. Because 1 into 1 is 1, 5 fours are 20. Radical form, exponential form. Seventh root of 3 square is equal to, this is the radical form. In the exponential form, it will be, write 3 square as it is. The seventh root will become the whole power 1 by 7. So this is nothing but 3 to the power 2 into 1 by 7. Multiply the powers. So that is equal to 3 to the power 2 by 7. This is the exponential form. Exponential form. This is the radical form. Okay, so now here we start from the outermost radical. Outermost radical. Okay, this is the expression given. Now see here, look very carefully. I have written this one as it is. I'm just getting rid of the outermost radical. Okay, so see, this I've written as it is. Cube root of square root of x square. See, how do you read this? Fourth root of cube root of x square. How do we read this? Fourth root of cube root of x square. Now, how do we simplify this? We start from the outermost radical. Like, how do you cabbage, like how do you get the leaves out? So you peel from the outermost, no? You start peeling from the outermost. So like that. Remove the outermost radical. So that becomes 1 by 4. This fourth root becomes 1 by 4. The rest of it I've written as it is. So write this as it is. This one, write it as it is. And fourth root becomes to the power 1 by 4. Now remove this one. Now remove this one. Cube root of x square. Now remove this cube root. So write this x square as it is. Write this x square as it is. This cube root becomes to the power 1 by 3. And the whole power 1 by 4, which is already there. Now there are many. Now we have removed all the radicals. All this you've removed. Now there are many powers. Multiply the powers. 2 into 1 by 3 into 1 by 4. Multiply the powers. And if you can simplify, you can simplify. So see, your 2 ones are 2 twos are. 2 ones are 2 twos are. 2 ones are 2 twos are. So it is 1 into 1, 1, 1 into 1, 1 by 3 twos are 6. Wasn't that very easy to understand, children?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes,
Very good.
ma'am.
No? Somebody said no? Yes or no? Okay. So it is easy. That's what it is. That's all. So start removing from the, how do we simplify this? Start removing from the outermost radical. You can also remove from the innermost radical. We'll do that. We'll first get used to one of it. So this is how we do it. Okay. So here also, you can see that everything is in the radical form. Everything is in the radical form. So we'll write all this in the exponential form. Cube root of 3, 3 to the power 1 by 3. Fourth root of 3, 3 to the power 1 by 4. 12th root of 243. 12th root of 243 is 243 to the power 1 by 12, not to the power 12, 1 by 12. Reciprocal. 3 means 1 by 3, 4 is 1 by 4, 12 is 1 by 12. Yeah. Now I'm going to show the answer. All of you go through and I'll ask one of you to, help me work this. Yeah. One second, children. Okay. Okay, so class, use the emoji, raise your hand. So we have Swati, Aniruddhan, Bhavishya, Sahana, Sadhna and Sabarna, Abhishek, Laksha, Prenu, Mritsa, Niveda, Neha and Roshni. Are you there, Roshni? Yeah. Roshni, can you
Yes,
see my screen, Roshni?
yes, ma'am.
Okay. All right, children. Yes. Go through this answer. Then I'll not be on this slide. I'll take you to this slide and you have to tell me how to work it. Yes. And also give me a minute. I'll just come back. Yeah, Amritsar.
Ma'am,
Yeah, tell me.
ma'am, cube root of 3 can be written as 3 to the power 1 by 3.
Okay.
And into fourth root of 3 can be written as 3 to the power 1 by 4.
Okay.
12th root of 243. 243 can be written as 3 to the power 5, ma'am.
No, first step we should write 243 to the power 1 by 12. Okay,
Yes,
next. Yeah, next.
3 to the power 1 by 3 into 3 to the power 1 by 4 into 3 to the power 5 into the whole power 1 by 12.
Okay. Roshni, how is it 3 to the power 5? How do we find out that? Roshni?
Ma'am, when we express 243, the 5 will come and we take 1/5 from it.
No. Okay, Roshni, what is 27 in base 3? What is 27 in base 3?
Three power 1 by 27.
No. 27 is, how do you express 27 in base 3? 3 to the power 3, right? 3
Yes,
cubed is 27. 3 into 3 into 3 is 27. And how do you do that? 27, 3 9s are 3 3s are 3 1s are. So 27 is equal to 3 to the power 3. So that's how you find for 243 also. 243. 3 8s are 1s are 81. 3 27. 3 9. 3 3 3 1. So 243 is equal to 3 into 3 into 3 into 3 into 3, which is nothing but 3 to the power 5. Yeah, Amritsar, continue.
Yes, ma'am. And all the bases are same, so we should
No.
use
One more step we have. No. One more step. 3 to
yes,
the
ma'am.
power 1 by 3 into 3 to the
Into
power 1
3
by
to
4 into
into 3 to the power 5 by 12, ma'am.
how? What do you do with 5 and 1?
Ma'am, it's like a power m in the whole power n. So when we simplify, we'll get a power m into n. So
You'll have to
5
multiply
into
the powers. Correct.
yes, ma'am.
5 into 1 by 12, which is 5 by 12. Very good. Very good. Okay, Allah. Thank you, Amritsar. Very good. Aniruddhan, continue.
Ma'am,
Yeah, I can hear you. Tell me.
3, we take 3 as a base, ma'am. Whole base, ma'am. 3, 3 to the power of 1 by 3 into 3 into 1 by 4 into 5 by 12, ma'am.
Do you multiply the powers or add the powers?
Add, ma'am. Sorry, ma'am.
Add. But you said 1 by 3 into 1 by 4.
I saw the same, so I confused.
Yeah, now tell me correctly.
1 by 3 plus 1 by 4 plus 5 by 12.
Very good. Next. What's the LCM of 3, 4, and 12?
12, ma'am.
12. So 3 to the power 12. I'm sorry, 3 to the power 12 is the common denominator.
Yes,
So
ma'am.
1 by 3 plus 1 by 4 plus 5 by 12. So when you take the LCM 12, what do you get? 3 into 4 is 12. So into 4 here.
4, ma'am.
So 4 plus here
3,
into
ma'am.
3
3, ma'am.
into
And 5 is the base, ma'am. 1, ma'am.
5. So you get 4 plus 3 plus 5. That is equal to
ma'am.
3 to the power
12 by 12. Ma'am.
12 by 12. And what is 12 by 12?
3, ma'am.
What is 12 by 12?
1, ma'am.
1. 12 by 12 is 1. And 3 to the power 1 is 3. Very good. Good job, Nitsa and Aniruddhan. Very good. I hope all of you understood that.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
All right.
Yes, ma'am.
Very nice, children. Yeah. Yeah, I'll show you the answer. I want one of you to explain this one. Go through the answer. I'll ask one of you to explain. Always remember, see, like, how are you able to write it like this? We are expressing 250 as a product of its primes, 16 as a product of primes, 54 as a product of primes. So this is the method. 250 in the rough column, you should do this. 2 125 times, then 5 25 times, 5 5s 5 1s like this. So 250 is equal to 2 into 5 into 5 into 5. That's what I've written here. So how did suddenly 250 become this? Using this method. Yeah. I'll ask one of you to explain. Go through the answer. I'm just coming, children. Just a minute. Yeah. So this time, Niveda?
Yes, ma'am.
Yeah, tell me.
Ma'am, first we are 3 root 250. We are by doing prime factors.
No, it's
3
not 3
root
root 250. Please read that correctly. It's not 3 root. You know what is 3 root 250? 3
cube
root 250 is like this. What is
cube
this?
root
Cube root of
250
cube root
of 250. Cube root 2 into 5 into 5 into 5.
No. 1 minute. First, we need to write the given expression. Read the second
Yes.
part. Cube root of 250 plus
7 cube root 16
7 into cube root of 16 minus
4 into cube root of 54.
4 into cube root of 54. Very good. Yeah. This is equal to
Cube root 2 into 5 into 5.
into 5. Okay, no problem. 5 5s are 25, 25 5s are 125. 125 into 2 is 250. Correct. Plus 7 cube root of
2 into 2 into 2 into 2.
very good. Then minus 4
4
into cube root of
2 into 3 into 3 into 3.
yeah. Very good. Next step.
After that, we have to make these steps into exponent form. So cube root 2 into 5 cube plus
No.
cube root 2 into 5 cube.
Cube root 2 into 5 cube. No.
5.
No problem. Maybe I've understood, but you're not expressing it correctly. This is down. So like 8th standard, we have learned no cube roots and square roots. So from that, you can understand this.
Yes.
Yeah, who can tell me? Who can help me proceed? No problem, Niveda. I'm sure you've understood. You're not able to express. No problem. Who can continue this?
Ma'am, can I, ma'am?
Yeah, who's that?
Ma'am, Neha.
Oh, Neha. Hi, Neha. Yes, Neha.
Ma'am, we can write as cube root of 2 into 5 power 3, ma'am. The whole cube.
Okay, have I written that step? Actually, that step is not needed. Okay, I have written it. Is it? Okay, fine. Oh, so was that what you were trying to say? Who's that? Niveda?
Mom?
You were trying to see that, is it? 2 into 5 cubed?
Yes, mom.
Okay, let me go back to, Niveda. Okay, fine. Actually, that step is not needed. So I was expecting the next one. I was expecting the next step that there are 3 5s. See, under the cube root, there are 3 5s. So of the 3 5s, 1 5 will come out.
Yes, mom.
Under the cube root, we have 3 5s. So from 3 5s, 1 5 comes out. And what is remaining? A 2. Cube root of 2. I was expecting this. I'm sorry, I didn't realize that I have written this step. This is optional actually. It's not wrong. This, somebody's mic is enabled. Please disable your mic. There's some background noise. This step, I didn't realize I had written it. I'm sorry. It's not wrong. It's correct. But it's not needed also. You can directly write this. You can directly write this step. Okay, sorry. I think Niveda was trying to say that step. Yeah, plus. Continue. Niveda, continue. Neha, I'll come back to you. Yeah, Niveda.
Plus 7 into 2 cube root 2.
Okay, 1 minute, 1 minute. Let me write that step. So you're telling me it is cube root of 2 into 5 cubed for the first part, then plus 7 into cube root of 2 into 2 cubed. I think you're trying to say this, right?
Yes,
So I'll
ma'am.
read it. I'll read it. See here, cube root of 2 into 5 cubed plus 7 into cube root of 7 into cube root of 2 into 2 cubed minus 4 into cube root of, tell me.
2 into 3 cube.
2 into 3 cubed. Okay, very good. Next one. Next step.
5 cube root of 2.
Yeah, because from 3 5s, 1 5 comes out. Correct.
7 into 2 cube root of 2.
Very good. Then
Minus 4 into 3 cube root of 2.
very good. Very good. Next step. Okay, Neha will continue now. Neha, thank you, Niveda. You were right so far. Very good. Neha, continue.
Ma'am, we can write as 5 into cube root 2 plus 14 into cube root 2 minus 12 into cube root 2.
Very good. Cube root of 2. Very good. Next step.
Ma'am, we can write as 5 into 2 power 1 by 3.
No. After this, I'll tell you what. So now, okay, Neha, what is 5x? What is 5x plus 14x minus 12x? Just look at this one as x, Neha. Cube root of 2, no? Read that as x. What is 5x? See, here also you have cube root of 2. Read it as x. Cube root of 2. Read it as x. Now, what is 5x plus 14x minus 12x? 5x
Ma'am,
plus
17x.
14x.
17x is coming.
No, I'm not getting 17x. What is 14x minus 12x?
Ma'am, 12x.
Yes, 14x minus 12x is 2x. 2x plus 5x is 7x. Correct? Not 17. 7.
Okay.
Okay, now 7x you said. No, but what is x? Cube root of 2, correct?
Yes, ma'am.
So 7 into cube root of 2. Do you understand?
Yes, ma'am. Yes, ma'am.
Look, see, everywhere we have cube root of 2, cube root of 2, cube root of 2. So it's like 5x plus 14x minus 12x. And that, so when you simplify that, you get 7x. So that means 7 cube root of 2. 7 into cube root of 2.
Okay, ma'am.
That's it. You can leave it there. That's the answer. Understood, all of you?
Yes, ma'am.
I'll just give you another 2 minutes time, children. Please go through the answer again. Yeah. Now go through this one, children. You can see two methods. I worked it in two different ways. Go through the first method. I'll give you 3 minutes for this. And one of you will explain. Go through the first method. All right. Swati?
Yes, ma'am.
Yeah, tell me.
And the first or the second method?
First method.
Yes, ma'am. Ma'am, 625 can be expressed to its power in its prime factorization. It can be expressed as 5 to the power 4. And
Okay. No, just
8.
tell me. So what do I write like? Should I write square root of 5 to the power 4? What should I write here? Is equal to?
M is equal to square root of 5 to the power 4.
Okay.
Minus 8 cube root of 5 to the power 3.
5 to the power 3? 81 is 5 to the power 3. Yeah? No, 1. Oh, sorry. I forgot. I was in 81. Yeah, 121 is 5 to the power 3. Sorry. Yes.
Plus 4th root of 3 to the power 4, ma'am.
Okay. Plus 15 into 5th root of
2 to the power 5, ma'am.
Very good. Next step.
Ma'am, from here, 5 can be written as 5 into 5 into 5 into 5, and from the group of 2 5s, 1 5 comes out, and another group of 5, 1 5 comes out, so it's 5 to the power 2.
5 square, yeah. So 5 to the power 4 means 5 into 5 into 5 into 5. There are 4 5s under the square root. So from 2 5s, 1 5 comes out. From these 2 5s, 1 5 comes out. So 5 square comes out, correct? Minus?
Minus 5 cubed, like 1 5 comes out, and it's 8 into 5.
Yeah, correct. So cube root of 5 cube. That means under the cube root, there are 3 5s. Under the cube root, there are 3 5s. So from 3 5s, 1 5 will come out of the cube root. 1 5 will come out. Very good. Plus?
And from 4th root of 3 to the power 4, 3 comes out. So it's 3 plus 15, and from 5 2s, 1 2 comes out. So it's 15 into 2.
Correct. Next step.
And after simplifying, we get 25 minus 40 plus 3 plus 30. So when simplifying, we'll be getting, calculate. We get 18 now.
Minus 15 plus 33. Yeah, 18. Correct. 18. Very good, Swati. Very good. See the next one, children. The other method. Who here is not given a chance? Prenu, have you answered anything? Prenu?
No, ma'am.
Yeah, try this one. The second method.
Yes, ma'am.
square root of 625 minus 8 into cube root of 125 plus fourth root of 81 plus 15 into fifth root of 32
Very good. You read it
equals
perfectly. Very good. Yeah, is equal to
625 into 1 by 2.
into 1 by 2.
Yes, ma'am. Minus 8 in
No,
8
no.
in
It's not 625 into 1 by 2.
625 whole power 1 by 2.
625 raised to the power 1 by 2. Raised to the power 1 by 2. 625 raised to the power 1 by 2.
Yes, ma'am. Minus 8 into 125 raised to the power 1 by 3
Very good.
plus 81 raised to the power 1 by 4
Very good.
plus 15 into 32 raised to the power 1 by 5.
Very good. Next step.
Now, when we expressed in 625 in prime factor, we will get 25 square now. Square into 1 by 2 minus 8 into 125 is expressed as 5 cube into 1 by 3 plus 81 is expressed as 3 to the power 4 into 1 by 4.
Very good.
15 into 32 is expressed as 2 to the power 5 into 1 by 5.
Very good, Prenu. Very good. Next step.
25 2 into 1 by 2 minus 8 into
No, no. What did he say?
25 raised to the power 2 into 1 by 2.
You're writing that as it is, huh?
Yes, ma'am.
No. No. You must cancel. No, this 2 and 2 can get cancelled, right?
Yes, ma'am. Next step.
Can tell me the other things. Yeah, tell me the other things that will get cancelled.
Uh,
3 and 3, 4 and 4,
yes,
5
3
and
and
5,
3.
they get cancelled. Yeah, now tell me. So it will be 25.
25 minus 8 into 5, 40 plus 3 plus 15 into 2, 30.
Very good.
So when we simplify all, it is 18, ma'am.
80. Okay, very good. Prenu, very good. Yeah, now children, I'll wait for another 2 minutes. Go through both the methods, and if you have any doubts, you can ask me. Yeah, children, please feel free to ask me any question, any doubts. Okay. Yeah. Check this one, go through this. So let me just tell you how I have started the answer. So it's like this, it's multiplication everywhere. See how, what is this? This is -2 into cube root of 5 into cube root of 5 into 3 into cube root of 5 into 4 into cube root of 5. It's a product everywhere. It's multiplication everywhere. See, -2 into cube root of 5 into cube root of 5 into 3 into cube root of 5 into 4 into cube root of 5. It's product, it's multiplication everywhere. So what you can do is you can multiply these numbers -2 into 3 into 4. That's what you see here. -2 into 3 into 4. And then cube root of 5 into cube root of 5 into cube root of 5 into cube root of 5. So that's what you see here. It's like this, children. See, supposing you have, like 2a. See, just imagine this. See, imagine all this as A, children. A, this one is A. This is A. This is A and this is A. So if the question is 2a minus 2a into 3a into 4a. Okay. If it's like this, I'm just imagining cube root of 5 as A. Okay, so supposing it's -2a into 3a into 4a. So then what would you do? You will say -2 into 3 into 4. Then you'll multiply all the a's into a into a into a into a. So then 4 3s are 12, 12 2s are 24. So -24, and then you will work this. In the same way here, I've written the numbers here, and then a cube root of 5, cube root of 5, cube root of 5 4 times. So this product is -24. And here, see, like when you have, when you have cube root of a into, listen carefully, children. When you have cube root of a into cube root of b into cube root of c, you can write, cube root of c, you can write everything under the same cube root of a into b into c. If it's a product, if it's multiplication, and everything is under the cube root, you can write one cube root symbol and write A into B into C. So here, that's what I've done. Cube root of 5, 5, 5, 5, 4 times. Separately, we have a product. So I put this cube root symbol and written 5 into 5 into 5 into 5 under the cube root. So now from 3 5s, 1 5 comes out because cube root, no? So from 3 5s, 1 5 comes out. These 3 5s, this 5 comes out. So this 5 remains under the cube root, not square root. This 5 remains under the cube root. So you can see here. And now minus 24 into 5 is minus 120 into cube root of 5. Yeah, now go through, children. This is understood, children. Shall we go to the next one?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
All right, children. Now comes the I shouldn't say problem, but a new type. Okay, so see here, how do we do this? 5 into cube root of 4 into square root of 3. Into square root of 3. 5 into cube root of 4 into square root of 3. Now you cannot write this as cube root of 4 into 3. You cannot write it like this because this is cube root, this is cube root, this is square root. So you cannot write cube root of 4 into 3 because this is under the square, excuse me, this is under the square root. So now how do we do this? Okay, so now let me take up only this one, children. Let me just take up only this part, cube root of 4, okay, and square root of 3. Listen to me very carefully. This is 4 to the power 1 by 3. This is 3 to the power 1 by 3. Am I, oh, sorry, 1 by 2. Am I right, children?
Yes, ma'am.
Yeah. See, forget this question. I'm doing something else. Forget this question. I'm not trying to answer this question. I'm using this question and trying to teach you something else. I'm trying to share something else. So cube root of 4 and square root of 3 is equal to 4 to the power 1 by 3 and 3 raised to the power 1 by 2. Now, what are the denominators in the two expressions? What are the denominators in the two expressions?
3 and 2.
Yeah, in the fractions. Okay, so 3 and 2. What is the LCM of 3 and 2?
6.
6. So how will 3 become 6? You should, okay, so you can do this in the next step actually. Okay, so this is equal to 4 to the power 1 by 3 into 2 by 2. Equivalent fractions. You've been doing this in 4th standard also. Your teacher will tell you, write 4 fractions equivalent to 1 by 3. So don't you remember doing this? Then you will write 1 by 3 into 3 by 3. Then you'll write 1 by 4 into 4 by 4. I'm sure you've already done this sum. So like that here into 2 by 2. So in here it will be 3 to the power 1 by 2 into 3 by 3. So what is this, children? 4 to the power 2 by 6, correct? 3 to the power?
3 by 6.
From 3 by
3 by 6. Now you can write this one as 4 square, the whole power 1 by 6. Think about it. 3 cubed, the whole power 1 by 6. Because, I'll tell you why. Because 2 by 6 is nothing but 2 into 1 by 6. And 3 by 6 is nothing but 3 into 1 by 6. Just see if you all agree with this. 2 by 6 is 2 into 1 by 6, correct?
Yes, ma'am.
And 3 by 6 is
ma'am.
3 into 1 by 6. So that's what I've written here. See here, when you write the powers like this, you have to multiply, no? 4 square, the whole raised to 1 by 6. 2 into 1 by 6, 3 into 1 by 6. Can you see that?
Yes, ma'am.
We know when there are many powers, we have to multiply the powers. When there are many powers, we have to multiply the powers. So here the powers are 2 and 1 by 6. So that means 2 into 1 by 6, which is 2 by 6. Now, is this correct? 16 to the power 1 by 6, is this correct? Four square is 16, children. 4 square is 16. And what is 3 cubed?
27.
27.
Yeah. Now see, the powers are the same. 1 by 6, 1 by 6. Now supposing you're asked to compare. Supposing the question is compare. Compare. Okay. Compare cube root of 4 and square root of 3. You have to put the symbol. Compare means you'll have to put the symbol. Equal to or less than, greater than symbol. Okay, now which is bigger, children? Now the powers are the same. So you can compare the bases, 16 and 27. So which is bigger? 27 to the power 1 by 6. That means square root of 3 is bigger. Yes or no, children? Understand?
Yes, ma'am.
Yes, ma'am.
So let me give you try this, children. Bring both to the same power, okay? Supposing you have cube root of 2 and 4th root of 3. Yeah, do this. Bring both to the same power. So let me start for you. So this is 2 to the power 1 by 3. This is 3 to the power 1 by 4. Yeah, now you have to compare. You have to compare cube root of 2 and 4th root of 3, which is, you'll have to use the correct sign, whether it is less than, greater than, or equal to. Yeah, do this. I'll just come back, children. Please work on this. I'll just come back. Yeah, children. Yeah, who's not answered anything so far? Meaning, I have not called out to whom so far? Can volunteer to answer? Yes?
Bhavishya.
Bhavishya? Bhavishya, yeah. Yes, Bhavishya, tell me.
Ma'am, 1 by 3 into 4 by 4, ma'am.
Okay. Here?
So 4 by 3, 1 by 4 into 3 by 2.
Very good. Next step here, put the power.
By 12.
Yeah,
And 3 to the power 3 by 12, ma'am.
very good. Here,
Then next 2 to the power 4 the whole power 1 by 12.
very good.
3 to the power 3 the whole power 1 by 12.
Very good.
So 2 to the power 4 is 16 the whole power 1 by 12.
Perfect.
And 3 to the power 3 is 27 the whole power 1 by 12.
Correct. So which is greater or which is smaller?
Ma'am, 4th root 3 is greater and cube root 2 is smaller.
Correct. Fourth root of 3 is greater than the cube root of 2 because now they are raised to the same power 1 by 12. So you can compare the bases. Now since they are raised to the same power 1 by 12, you can compare the bases. 16, 27. 27 is greater, which means fourth root of 3 is greater. So this is the symbol. So this is how we compare radicals. This is how we compare radicals. Now using this idea, we have to work the sum. Now what you have learned now, see, what have we understood now through this example? How to compare expressions which are in the radical form. Now these are certain terms are not used in CBSE, so I'm not using it. This is called a surd of the third order. This is called a surd or a radical of the third order. This is of the fourth order. This is order 3. This is order 4. This is order 3. This is order 4. Order 3, order 4. So how do you compare? You'll have to bring them to the same order and then compare. So that's what we did here. Now I think you can understand this answer, children. I'll just tell you what is here. So we are bringing 1 by 3 and 1 by 2 to the same base 6. Same base 6. Yeah. So then I think you can follow till here. Now here you can see that 16 and 27, the connecting sign is multiplication and they are raised to the same power 1 by 6. So you can multiply that 16 into 27 and raise it to the same power 1 by 6. 16 into 27 is 432 to the power 1 by 6. So this is not, you cannot multiply 5 and 432 because this is 432 to the power 1 by 6. So you cannot multiply 5 and 432. So this is nothing but the sixth root of 432. This can be written as the sixth root of 432. So this is the answer. 5 into sixth root of 432 is the answer. Yeah, go through, children. I'll not ask anybody to explain this because we already, understood it in the with the early example. So just go through this and we'll go to the next one. Yeah.
Ma'am,
Yeah.
ma'am, I have to go for another class, ma'am.
Niveda, is it? Who's that?
Sadhana.
Oh,
Sadhana.
Sadhana and Sabarna. All right, children. Okay, fine. I'll share the recording at the end of the meeting.
Okay.
So the rest of it you can watch the recording. All right, girls. Thank you.
Okay. Thank you.
Yeah. Thank you, girls. Bye.
Ma'am,
Yeah.
ma'am,
Roshni?
Mritsa, ma'am.
Amritsa, yes.
Ma'am, I too having class, ma'am.
Okay, darling. Fine. You can leave and make use of the recording. Okay.
Yes, ma'am. Thank you, ma'am.
Thank you. See you. All right. Anyways, I'll be sharing all this with you so you can look at the answer later also. See the next one, children. This one of you will explain. Go through this. Okay, so who wants to explain this? Neha?
Can I?
One second. Yeah, who's that?
Sahana, ma'am.
Sahana. Yes, Sahana. Yes, Sahana, please tell me.
Root 3.
You joined late, is it, Sahana?
No, ma'am.
You're there in the beginning of the meeting?
Yes, ma'am.
Okay. Yeah, tell me.
Ma'am, 3 power 1 by 2 into 2 power 1 by 3.
Very good.
3 power 1 by 2 into 3 by 3.
Okay.
2 power 1 by 3 into 2 by 2.
Very good. Next step.
3 power 3 by 6. 2 power 2 by 6.
Very good.
3 cube power 1 by 6. 2 cube whole power 1 by 6.
2 square. 2 square.
Okay, ma'am.
7.
7. 27, ma'am. Whole power 1 by 6. 4 whole power 1 by 6.
Now, what is the rule here? What's the law of exponent here? A to the power m into
b to the power m, ma'am.
is equal to complete the rule. What's the law? A to the power m into b to the power m is equal to a into b.
A into b power m, ma'am.
Yeah. So what will you do here?
27 into 4 power 1 by 6.
Correct. And what is 27 into 4?
108, ma'am.
To the power 1 by 6. Very good, Sahana. Very good, Sahana. I hope all of you have understood the same way she's understood. Sahana, is it clear, all of you?
Yes, ma'am.
Yes,
Very
ma'am.
good. Very nice, children. Next one. So you can follow. See, it's all similar, okay? Similar, these are. Yeah, this is the next type.
Ma'am.
Yeah?
I'm Abhishek, ma'am.
Yes, Abhishek?
I'm sorry for disturbance, ma'am. Ma'am, we are going to travel towards the forest side, ma'am. So there will be no internet connection, ma'am.
Oh, so you'll be leaving the meeting now?
Yes, ma'am. Can I
Okay.
use the recording, ma'am?
Yes, yes. Do that later. Okay? Yeah.
Okay, thank you, ma'am.
Okay, thank you. See you. Yeah. So children, before we do this, I have to help you recall two things of exponents from 8th standard. Now, consider 7 by 9 or 7 by 11, the whole power minus 3. All right. Now, if you want to write the equivalent of this one, see, like, what do I mean by equivalent? Now you all know that 2 by 5, the equivalent of this is 4 by 10, 6 by 15. All these are equal. Like that, if you want to write the equivalent of 7 by 11, the whole power minus 3, use two rules. See, when we have the exponential form, there are two components, base and power. Whenever you see an expression in the exponential form, there are two components. One is the base, the other is the power. Base and power. Remember this rule, reciprocal of the base. Reciprocal of the base. Okay, then negative of the power. Memorize this, negative of the power. Power and base are the two components. Base and power are the two components when you see an expression in the exponential form. What should you do with the base? Reciprocal of the base. Power, negative of the power. I'll wait for a minute. Memorize that. Okay. So now if you want to write the equivalent of 7 by 11 to the power, say, -5, you must write the reciprocal of the base and the negative of the power. Negative of the power meaning change the sign. Negative of the power does not mean you should put a minus sign. Write the opposite sign. -5 will become +5. +5 will become -5. Now these two are equal. These two are equal. They're equal. Now supposing you have 8 by 9, the whole power 11. You want to write this in a different way. You want to write this in a different way. So what should you do? Take the reciprocal of the base. 8 by 9 will become 9 by 8. And write the negative of the power. +11 will become -11. Now these two are equal. So to write the equivalent, you should take the reciprocal of the base and write the negative of the power. Now, if you want to write the reciprocal, of this one, the reciprocal of 7 by 9 to the power 8 can be written in two ways. Equivalent, you can write it in only one way. Reciprocal, you can do it in two ways. For reciprocal, what you should do is, we learned two rules, right? Reciprocal of the base, negative of the power. If you change both, you're writing the equivalent. If you do only one of the two, then you're writing the reciprocal. Which means, supposing I write 7 by 9 as 9 by 7. That is, I've taken the reciprocal of the base. And actually, I should write the negative of the power. No, I write the power as it is. That means this is the reciprocal, not equivalent. The other way is, I don't write the reciprocal of the base. I write the base as it is. Then 8, I write +8, I write as -8. That is if I do only one of the two changes. The two changes are reciprocal of the base, negative of the power. If you make both the changes, you're writing the equivalent. If you do only one of the two changes, then you're writing the reciprocal. So here you have taken the reciprocal of the base, but written the power as it is. Here you have written the base as it is and written the negative of the power. So if you do one of the two, it is reciprocal. If you make both the changes equivalent. Understand, children?
Yes, ma'am.
Yeah. Now let's answer this. 7 by 9 the whole power 8 into 9 by 7 to the power minus 4 is equal to 7 by 9 to the power 3x. Now you should decide what base you want to have everywhere. Since this is 7 by 9 and 7 by 9 here, you want this also to be 7 by 9. You want this also to be 7 by 9. So we'll write this 7 by 9 to the power 8 as it is equal to 7 by 9 to the power 3x as it is. This 9 by 7, you want it to become 7 by 9. Now remember, you cannot simply write the reciprocal. Next step, you should write its equivalent only. You cannot simply write the reciprocal. Reciprocal you must write only if you're asked to write the reciprocal. Supposing they ask you to write the reciprocal of 5, then you will write the reciprocal of 5 is 1 by 5. Now for this in the next step, you have to write the equivalent. You cannot write the reciprocal. Reciprocal you can write only if they ask you to write the reciprocal. Otherwise, you should always write the equivalent. So what's the equivalent of 9 by 7? So reciprocal of the base, negative of the power. Now you should simplify this one. Bases are same and it's multiplication, so add the powers. So 7 by 9 to the power 8 plus 4, which is 12, is equal to 7 by 9 to the power 3x. Now, on both the sides, you have the same base. On both the sides of the equal to sign, you have the same base, 7 by 9, 7 by 9. So when bases are same, we can equate the powers. You can equate the power. So 3x is equal to 12. 3x is equal to 12. X is equal to 12 by 3. The value of x is 4. I think I've done it both the ways. No, only one way I've done it. Okay. Now this is what I've done there, children. Let's do it in another way. Now supposing you want the base to be 9 by 7 everywhere. You want the base to be 9 by 7 everywhere. So 7 by 9 will become 9 by 7. Reciprocal of the base, negative of the power. You should always write the equivalent. That is, you should change both. 7 by 9 becomes 9 by 7, plus 8 becomes minus 8. So the base has become 9 by 7 now. Into write this as it is. Write this one as it is equal to 7 by 9 becomes 9 by 7, plus 3x becomes minus 3x. Now, bases are same. So you can add the powers. It's multiplication, so you can add the powers. So it'll be minus 8 plus minus 4 is equal to 9 by 7 to the power minus 3x. So 9 by 7 to the power minus 8 minus 4 is minus 12 is equal to 9 by 7 to the power minus 3x. Now base are same on both the sides, so equating the powers. Minus 3x is equal to minus 12, minus gets cancelled, x is equal to 12 by 3, x is equal to 4. So you'll get the same answer in both. So I hope you understand this, children. When there is no sign in the middle, it's multiplication. There's no sign here. That means it's multiplication. Is this understood, children?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah.
Yes, ma'am.
All right. Yeah, I'll stop with this one. Till here, I'll share the presentation. All this we have to discuss. You can't do it yourself. I'm just seeing how much is there. Okay, 1 minute. Yeah, we just understand this and wind up the session for today. Till here, I'll share this presentations, children. Please work on all this in your tuition classwork notebook. So see this one. We are given that 5 to the power 3x is equal to 125. So how do you work this? 5 to the power 3x is equal to 125, but 125 can be written as 5 cubed. 125 can be written as 5 cubed. So bases are same on both the sides. Equate the powers. 3x is equal to 3. Bases are same on both the sides. So equating the powers, 3x is equal to 3, x is equal to 3 by 3, which is 1. X is equal to 3 by 3, which is 1. Similarly, for 10 to the power y is equal to 0.001. So 10 to the power y is equal to, you can write this as 1 by 1 followed by 3 zeros, because 1, 2, 3 places you'll have to shift the decimal point. So 1 by 1000. So 10 to the power y is equal to 1 by 1000 is 10 cubed. 10 cubed. 1000 is 10 cubed. So 10 to the power y is equal to, now remember, whenever you change the position from the denominator, if it comes to the numerator, the power become negative, -3. Or you can understand this method. So all this of exponents we've seen last year. It's not that I'm not telling you now. This is all of 8th standard. 10 to the power y is equal to 1 by 10 the whole cube, because 1 by 10 cubed is 1 by 10 the whole cube. Now, how do you write the equivalent? Reciprocal of the base, negative of the power. How do you write the equivalent? Reciprocal of the base, negative of the power. So this is nothing but 1 by 10 the whole cube. Now that is nothing but 10 to the power y is equal to reciprocal of the base. 1 by 10 becomes 10 by 1, which is 10. Negative of the power. That's how you get this step. You write the equivalent in the next step. 1 by 10 reciprocal is 10. And plus 3 will become -3. So now you have 10 to the power y is equal to 10 to the power -3. So on equating the powers, we have y is equal to -3 because bases are same. So on equating the powers, we get y is equal to -3. The question is to find the value of x and the value of y. So using this, we find the value of x. Using this, we find the value of y. And in both, the method is when bases are same. So equating the powers. 3x is equal to 3, x is equal to 1. Here also, bases are same, 10, 10. So equating the powers, y is equal to -3. All right, Neha alone, I have to generate your, is Neha here? I don't know.
Mom, are you seeing me?
Hey, that's Niveda. I was asking Neha. Neha's not here. Okay, fine, children. So I'll share the recording. Okay, so those who have left the meeting are not here, so it doesn't make sense if I say that now. Fine, children. So I'll share this presentation. You know this library, right? In your portal, library questions and answers. Have you visited that?
Yes, Mom.
Yeah. So I'll post this PDF in the library in the portal. You will find it there. Go through, complete this in your work out all the sums we discussed in today's class in your tuition classwork notebook by the next class on Tuesday. All right?
Yes, ma'am.
Yeah.
Yes,
All
ma'am.
right,
Yes,
children.
ma'am.
So, very good. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Thank you.
Thank you, ma'am.
Thank you,
Thank
children.
you, ma'am.
Thank you.
Thank you. See you.